Hey guys, so I've been working on this project for a little bit over a year, and I wanted to show just how much things have changed. The prototype on the left is one of the first ones that we made a little bit after we launched in June 2017, and the one on the right is one that came out of production about a week ago, and it's such a significant difference figuring out how to polish this and getting all the fine touches on it. There is a total of 460 parts in here. It's a lot, and that doesn't include all the little terminations. For example, a cable has two ends to it, and there's lots of cables in there. We are considering that one part, but this considers a couple more because there's a screw and a spacer and a nut, so some things count for more than they get a fair share of. But what we've done here is really improve things. We've got a fingerprint proof coating that's also a cleaning agent that we put on the printers when they come off the line, and that definitely makes a difference. As you can see in the back where things are less polished, there's all kinds of residues and oils and fingerprints and things that can easily accumulate, but right now we're not seeing that effect. So the logo is finished. We didn't have that back in the day. It's a very nice, very strong metallic coating that we put on there. By far the biggest thing is the print quality, and the reason we got better print quality. Some of the earlier prototypes showed signs of what a professional printer should look like and not so much signs of what it should look like. We had some basic issues like not enough rigidity in the frame that caused there to be backlash, as well as some poor tuning of resonances and current and firmware, not enough bed heat power, things like that. But the big thing is definitely this Z platform, and that is something that was using threaded rods. This is a standard design, but for whatever reason, no matter how much the math and the FEA simulations showed that this rod, even though it's completely free, has almost no force in these directions against such a beefy rod that only bends, in theory, 10 or 20 microns, and there's multiple rods. It didn't seem to matter. We would always get some kind of wobble or wonky motion. And so we switched to this bed style, where we are using 4 belts in a sort of Corex Y twist. So that belt goes around, does a loop back down so that it's moving in the right direction. The back one does the same thing, it has the loop in it. And then the ones on the left side, they are just a straight pass through, so or ordinary loop around the pulley. Here you've got the pulley going through that slider is 3D printed, but all it's really doing is holding a bearing, and 2 bearings rather, that allowed us to tension this belt without losing or adding friction rather. These are tensioning points, and they've been refined and improved a little bit since. So that's how the Z platform works. It makes it very strong, very fast, and completely wobble free. So when we look at the end result, what we're seeing is very good print quality as far as how the layers look over the course of the print in the Z direction. Now, white's probably not the best color for a camera, but if you look at that side right there, that's really what we're going for. There we go. As opposed to these kind of periodic striations that you see in the original version of the printer. It just moves faster. You can do Z-hop. There's very little backlash in it. Another thing that we did is the original version of this printer had the motor works inside, and that led to just a lot of assembly challenges and really an inability for the user to be able to customize their system. So what we did is about 7 months ago we announced that we're moving the motors to the back, giving you much better access to a simpler version of the system. So as you can see here, you could change that pulley. You can make your printer go super fast, 500 millimeters a second if you'd like. It's currently set up for about a 300, maybe a little less realistically, but you could also take this 20-tooth pulley down to as low as 14 and get a lot more force and still a pretty substantial speed, probably around 100 to 150 depending on which direction we're talking about. There's plenty of room to adjust things here. The other major difference is that everything is in the back so that it is much more accessible. This makes it easier to get into the electronics, inspect things, change things, add things, as opposed to what we had originally, which did constrain the system quite a bit. There was very little room to pack all this stuff in here, so it was a tricky endeavor. The Z platform, as you can see, was a less rigid version, much less rigid. It was actually just something that we reinforced in the front and started to realize that we need to go for a very rigid approach. So there's lots of beams in here. This is a fiberglass reinforced structure, and then there's the heating elements, and then the glass itself. The print head definitely went through a lot of revision as well. The original Core XY belts were using kind of a cheaper crimping system. We now have a dedicated clamp. I don't know if I can get in here. So that's the edge of it right in the center. And that goes all the way through, but what happens is the belts loop around and then they're just being squeezed together and the teeth interlace, as opposed to interlacing it with a crimp that you can't ever remove. It's actually a screwed in solution. Let's see, we got the cable chain. Rather than having that squished inside the frame, we have it moving freely, and we opted for this bridging design. So all you have to do is go to the bottom. Let's see if I can get a good angle on this. If you go to the bottom of this cable chain, put a little flathead screwdriver in there and twist it, and probably less than 30 seconds or a minute, you can get all of these different links out. And the solution there allows you to get in very quickly and either inspect or remove or add cables should you want to. We also have a much better cable organizing system, albeit this is still in revision. We're going to make a more rigid version of this that's cleaner and has more adjustability, but currently we have the most necessary components at the surface of this interface. So you've got your heater, PT1000, what effectively acts like a thermistor, and let's see, the fans. And then the motor wires are buried deeper in, although we do have one of the expansion slots showing. I'm sure that's going to change. We also finished the design of a PTFE tube system that we didn't have originally. Now, this is pretty important. We definitely have a lot of motor pull power on the extruder, and in a system like this that's very rigid, it really doesn't seem to matter whether you put filament directly in here or you pop out the PTFE tubes with the snap fit. Pop them in and feed from here. We think that this makes things just a little bit cleaner and easier to manage, but it is necessary to use these if you put the top window on and you're trying to use a heated chamber approach to the printer. Let's see if there's anything else in the extruder that's necessary to look at. No, I think we're good. Probably the other cool thing that we did that I think is really valuable for this printer is making the top and the front very easy to remove. The front especially has two strong magnets on the top and slightly weaker ones at the bottom. That makes it so that when you go to pull the panel off, it's like something from Star Trek. The bottom pops out first naturally, and then the top pops out. They're very strong magnets, as well as held in by a bit of adhesive at this interface, and they actually sit on that lip. Yeah, I think that's most of the major changes that we had in the last few months. All right. Let's take one last look.